Okay, all right. Let's move to our next speaker, Mr. Dongwei. Dongwei is an ARM fellow and the lead standard architect of the architecture and the technology group in ARM, and he leads the many industry standards. Also, Dom is a program evaluator of ABIT, the global accreditor of 4,300 STEM programs at 846 universities in 41 countries. His topic today is from PA risk to ARM. So, Wei, can you please take the floor?
Yeah, thank you. So I don't know if you can see this.
Yeah.
Yeah, so I have a bunch of Raspberry Pi devices at home as well. So this is not just for the kids. Actually, what we have in terms of developers, Raspberry Pi actually is a very good device. It uses the ARM SoC, right? It gives you the ability to do a lot of development on a very affordable and small device. So I think I'd like to thank Paula as well, from Broadcom Foundation and Raspberry Pi Foundation as well. All right, let me share what we have. So I think Paula has been talking about from the perspective of let me just have this from the perspective of the Raspberry Pi Foundation and Broadcom Foundation. What I'm going to be talking about is really trying to share some of my personal experiences, stepping into the STEM field to, whatever I have been doing in the more recent years. And I hope that by sharing some of the personal journey that could help our high school or middle school students to have a better understanding of what's potentially ahead of you. Everyone's journey is going to be different, but I hope that by sharing some of what I have been through could give you some sense of, what potentially a STEM, career would look like. Right. So yeah, again, a little bit of background from my side. I do a lot of system architecture for the computers. The most recent one is certainly with ARM. But before that, I have been going through a lot of other processor architectures as well. So I will share some of that experience. Before joining ARM, I was with Hewlett Packard Company for a very long time.
Don?
Yeah.
Could you swap the display?
Oh, sorry. Let's see. So you're seeing my main screen, is that the case? Okay.
Slideshow.
Yeah, I was trying to do a slideshow, but it was showing you the other screen, right?
Dr. Dongwei, you actually can just swap the display. On your left top, there's a button. When you do the slideshow.
Yeah, I was doing a slideshow, but
you can do the slideshow, then you will see that. So on your left top button, there's a swap displays. Do you see that? On your top left, yes.
All right, good.
Yes, good. Okay. Thank you, Mingyu.
Thank you. Yeah, it's too complicated, the setup here. Yeah, as was mentioned earlier, that I also am a program evaluator at the ABAT. ABAT basically is a an accreditation body that evaluates the colleges throughout the world, especially in the engineering and technology field. So I'm going to be sharing some of that experience. And then I also work on a lot of industry standards. I can talk about why the importance of the standards as well. So the reason I stepped into STEM was kind of interesting. So I came from the background that I was born in China, and I was raised over there throughout the college years. And that was in the 1980s. I'm sorry, I'm kind of showing my age as well, I guess. But at the time, there were a lot of, I guess, quote unquote, propaganda of, the Nobel Prize winners, right? A lot of the people were coming, from this effort to modernize the industry and so on. And then there were a lot of role models being presented at the time, especially those Nobel Prize winners. And these are mostly in the field of physics. And so these are Chinese Americans. These people were presented as models, role models for us. So it was very interesting. So I was very interested in the math early on in my very young ages. But these role models got me to look at the fields of physics. Right? Physics is really a pure science. You could go into a very deep, theoretical physics or device physics and so on. But eventually, I think as I grow up, I kind of get into this feeling that I really want to apply whatever the learning is from the science perspective and technology perspective. And I want to apply that to the real world, right? And try to design things and make sure whatever the knowledge we have gained would actually be able to produce devices or solve problems for the real world. So eventually I got to the engineering side. And initially it was the electronics engineering. And then throughout the years, it was becoming more and more into the computer side. So I think that, STEM itself is not a very isolated area. It's actually very broad. It's not only about science, it's also about philosophy, right? You still have to have the understanding of the world and then come up with ideas and then use science as your tool and produce the devices and the solutions through engineering. So it's not like when you move on to STEM, you're only limited to this small scope. Even for the engineering, it's a very wide range of disciplines as well, right? It's not just computer engineering. It's also electrical engineering, civil engineering, and bioengineering, right? All kinds of engineering disciplines that form this field. So it's very important that as young kids getting into the schools, learning the different subjects, you would want to explore different areas. It's not only about coding, right? Even though coding is a great tool to use. I've seen actually, a lot of the colleagues. It's actually interesting. Some of the people graduated with a philosophy degree or history degree or some other degrees, and yet they can code as good as I am or even better. So it really depends on this full understanding of how you come up with ideas, how you apply the science learnings into solving the real world problems. So for myself, I got involved with a lot of the processor architectures. So initially at school, I was doing, that was a long time ago. It was about these microcontrollers, Motorola, Intel, they kind of present an opportunity to create a control system that can monitor the world. And one of the very interesting project I did at the time was designing this quote unquote black box for the BOT system. You know BOT, right? I mean the light rail system in the Bay Area. So these kind of cars, forming the light rail trains, they also need to have something that can record the signals, just like the black box is doing for the airplanes, right? So you have to monitor not only the digital signals, but also the analog signals, all the events that are happening. So in case there is some sort of misbehavior, you would have a record to go back to. So that was very interesting. And then, of course, long time ago, there were a lot of processor architectures. Of course, you had the RISC processors at the time already, and you had bigger companies like IBM, HP, and Sun building Unix machines with these processors, very unique, very proprietary, right? So they build very big boxes that can run your banks or what have you. And then when I joined the workforce, it is around where the HP and Intel was creating this Itanian architecture, which is a 64-bit. The world was moving from 32-bit processors to 64-bit. So I was involved in that effort. That was very interesting, but not all the projects are necessarily going to be successful, even if companies like Intel or HP were behind the efforts, right? I mean, so if you're in the processor field, that Itanian architecture has pretty much failed. But there are a lot of learnings that people gain from that experience, and that came to be many the applications into the future processor architectures as well. So I got the opportunity. It was pretty unique. I got the opportunity to experience and involved in many of the more recent architectures as well. The x86, which is Intel AMD, right? And RISC-V is basically coming out of Berkeley. And then you had some China vendors doing their architecture, and of course I have been doing the ARM architecture for the last more than 10 years now. So very interesting to be able to go through quite a bit of that. And one of the key learnings I had was, silicon design certainly is very important. You need to design your CPUs and SoCs so that you can build devices like the Raspberry Pi, right? But what's important also is the system software actually brings the silicon to life. If you're just having the chip itself, it's not going to solve really any problems, right? It's just a chip, a device, or a board. But you have to have sufficient system software to get the operating system like Windows or Linux to run on these devices. And then, of course, that leads the foundation to let you develop applications on top, right? So from, even in the silicon itself, there are a lot of coding involved these days. There are microcode involved as well. But beyond that, when the system turns on, you have what's called the system firmware, and then you have the operating system, you have the applications. Everything is about coding at that point. So it is very important to understand this, this kind of development cycles and development environment for all these different code, right? And so it's also important, I think, a lot of people may be understanding the coding from the aspect of developing applications. And in that case, probably you don't need to know a lot about the computer itself. But system software, like the operating system, for those kind of software to run on the devices, you actually need to understand the CPUs, the GPUs, the I/O devices as well, right? So that's why I was kind of mentioning this interdisciplinary area of electrical engineering and computer science. And so you now have this field of computer engineering, which makes the people involved in that field to be experts in both hardware and software. So that's also very important. And it's also interesting, like, throughout the career, right? You would be facing a lot of opportunities, and you're also going to be facing a lot of failures as well. To me personally, when I came out of school trying to go the first job interview, right? And it was kind of interesting, like the engineer who asked me the question, he certainly came from this work environment. He wanted someone to jump on to work on these areas right away, right? So he was asking, how do you turn the x86 real mode to protected mode using the assembly code? And I had no idea what that is, right? So that means that there is a gap. I think it's still true today in the real world, where there is a gap between the academics and the industry. So what you learn from the schools, if you just take the courses, right, in the universities or wherever, and then you expect that whatever you have learned in these courses are going to be sufficient for the workforce is not necessarily true. I think in more cases than not, it is not true, right? I mean, it's not possible for the professors to teach you everything. And then the companies usually are focusing on their areas of development, and they would be asking these kind of questions very specific to whatever the work that they have in the workplace. So there is this gap, and how do you solve that, right? I think it is very important for the students to find opportunities while you get into the colleges, to find intern opportunities with the companies, so that you can have a kind of a feeling of what the industry is looking for, and also do more than just the coursework, right? I mean, you can try to find opportunities to work with the industry while at the school. So I already mentioned the rise and fall of the Itanium, right? And it was interesting, like, when I joined HP at the time, I was just a recent graduate, college graduate, right? But the company is like, throwing the new person onto this project right away and basically saying, okay, you need to represent our company to negotiate with companies like Intel, right? It was a very significant challenge because, as a college graduate, you typically, don't know the whole lot, right? I mean, you're supposed to just start to understand and learn, but in the real world, people were like, okay, you have this chance, you can represent us right away. And it is a challenge, of course, but it's also a great opportunity, right? So the opportunity doesn't necessarily come all the time, but when the opportunity appears, it's great if a person can grab it. And so and then there is an up and down, and there was a period of time when the project got delayed, and then HP had to ship products, right? And then most of the people were moved to some other products that the company has to ship. And I felt like I was the only one that was dealing with this project at the time. And so, in that kind of environment, you have to have the passion and commitment. You see the picture like, I feel like this is still going to be successful. I want to still lead the project forward, right? So the passion and commitment is very important. And not everything is lost in these kind of projects. And throughout the period, I have been working with Intel to create this new firmware standard. which now actually outlasted Itanium quite a bit. It's now being used everywhere, not only on x86, but also on ARM or RISC-V or any other architecture, right? It becomes a lingua franca for system firmware, basically between the hardware and operating systems. But that was very difficult to get to. Initially when we started to create this firmware standard, there were a lot of people in both companies who are basically like, over my dead body. I already have a solution, for previous generations of products. I want to continue to use that, right? I don't need anything new. So a change is always difficult. So you have to have the motivation. You have to basically work with a lot of partners to, to get to this ability to change the world. And the world is moving to software-defined these days, right? Not only in the networking, but also in vehicles, in infrastructure. So, silicon is only one part of it, and a lot of the development is based on software. So it's important to get there. In terms of career growth, I mean, I certainly went through, climbed the ladder, from being a college graduate all the way to, I think right now it's like the top of the technical career ladder, right? So how we can go through that is something that is not necessarily guaranteed, right? You have to look at the opportunities, like I mentioned, and also throughout the process, leadership is very important. I think when I saw a lot of the young kids entering into the workforce, some of them are very successful because they took the opportunity to take the leadership. Very important is take the ownership, right? So when there is a project, when there is some effort, there are a lot of people who are like, okay, so I'm only going to contribute a small piece of this. This whole big thing is going to be run by somebody else. I'm not going to be responsible for that, right? In that case, it's actually very, very difficult to have the career growth, because what you need to have is, regardless of what you do, taking the ownership, taking the leadership, and taking the partnership. It's not only about you. Everything in the workforce work area is a teamwork, right? So there's no competition between you and your peer in the team. You need to really work together to deliver the project. And broaden to, beyond that is the ecosystem play. So it's not just necessarily within your team or within your company. Sometimes a lot of the work is, across the industry, working with the partners, sometimes even working with the competitors. So there is this idea of, so some of the collaboration is with the competitors. So it's collaboration and competition. When those two work together, that's how we actually make progresses in the industry, right? And then, as I mentioned, as you grow your career path upwards, sometimes you lose track. For example, for me, I was like, in the middle of all the work and everything, right? I was like, kind of satisfied where I was. But then, my mentor was like, well, you have done so much. And if you look at what you have done, right, what are you going to be expecting in 5 years? And I wasn't having that kind of thinking at the time. I was like, focusing on the work every day and never looked at, the 5 years beyond, right? But I think it's very noble for the mentor to help me, realize in the big picture, and also build the confidence in me that, really I have done a lot of work. So, there's an opportunity to grow even further beyond that. So that's actually a very interesting situation. And understanding a big picture of your program or of your work is also very important, right? So for example, I was involved in this HP, the machine effort, which is supposed to be replacing this von Neumann architecture, which is what we have today in terms of a computer, right? So the idea in this machine effort is to basically say memory is more important than the CPU, right? So in that case, people are doing some proof of concept and want to develop some of the memory controllers as part of the efforts. And there was this debate as to whether we use ARM or RISC-V, right? And I guess at the time I already understand both of these architectures, and I was able to provide advices to the the ASIC team basically developing this memory controller, and they were very surprised. After I provided the recommendations to them, and they were very surprised that they could actually develop this memory controller in 2 weeks, right? So this tells you that understanding beyond your immediate work is also very important, and you can make contributions with that kind of knowledge. And in the case of the college accreditation reviews, and one of the things that I found in that effort is some of the trends in the STEM field, right? Computer itself becomes a critical element in almost all of the STEM fields, regardless of whether you are just doing the computer science or whether you are even doing the bioengineering or even medicine, right? So a lot of the algorithms today are based on math, and then artificial intelligence simulations, human genome, right? All these things, actually the human genome discovery requires a very powerful computer, right? The high performance computers. So, I think throughout the last decade or two, computer becomes more and more important in the STEM field. So as I already mentioned, the boundary between hardware and software are becoming less important because you have to have the two work together, right, to deliver a solution that actually solves the problems. Hardware alone or software alone wouldn't be able to deliver. So interdisciplinary development is very important. And writing and public presentations are also extremely important. As I participate in these reviews, we look at the curriculum of the colleges, and we always try to make sure the curriculum provides sufficient writing and also public presentation opportunities. And this is so important because it is the way that engineers or people communicate with other engineers or people working on the projects, right? And I personally have been involved in some cases where even some of the professors were not very good about the communication. So that professor was really good in terms of being able to write code and develop systems, right? He's a really good engineer, actually. So he can develop a lot of proof of concept products. He can write a lot of programs, doing a lot of examples. But teaching was very challenging for him because the ability to write, to present his mind is a very challenging situation, right? So that, as you can see, no matter how good you are in doing these development, if other people on your team or in other companies couldn't understand what you're doing, then that's going to be a hindrance. It's not going to be a very helpful situation. I think I already talked about the summer internship being very critical. It gives you the ability to connect to the real world and identify the gaps that you may have, and using that opportunity to not even connect to maybe your potential future employers, but also, maybe throughout the college years, making sure that you can have the opportunity to, gather the knowledges and information sufficient for your future work. So ABET program review is always a multidiscipline review. So all the engineering fields, all the people, different reviewers are forming this team together to go to a college to do the review. So that's how important it is to understand the need for the multidiscipline kind of coverage. And I think in the last minute, I will just kind of tell you about the importance of the standards work that I have been involved with. And people may wonder, why do we have to have standards, right? And it is really for the interoperability and compatibility, and making sure the software would just work for these systems. And a very simple example I have here, I think you may realize that if you travel internationally a bit, you would find that these power plugs are all different when you go to different countries. And that's really a pain, because if you don't have these adapters with you, then you have to either try to find an adapter somewhere, or maybe rent from the hotel or whatever, right? It's just a pain, and there's no reason why these cannot be just standardized with one connection, right? So yeah, unfortunately for many historical reasons, and sometimes every country has different opinions, that resulted in this kind of needless differentiations. It doesn't give you anything. It's just delivering power to your device, but it creates all kinds of problem when you don't have these adapters. And also on the right-hand side, I don't know if any of you would recognize all these things. If you are familiar with the computers in the last 10 years or more, you may have seen some of these ports, right? And I couldn't even recognize all of them, right now. You have to, look into the picture and see, yeah, that's the adapter the port that we have been using before. Too many of these things, it's needless differentiations, right? I mean, a lot of people want to create innovations, differentiations, but the innovations and differentiations would have to actually create real value. And just for the sake of difference, like these ports or the power plugs, that's not delivering any value to any customers, right? So I think throughout your future career, if you bear this in your mind, when you do the differentiation and innovations, please make sure your innovations are actually delivering values to human life and not more trouble to human experiences. So yeah, this is what I have so far. Any questions?
Yeah, I saw that there are many questions to you, Mr. Dongwei. And please unmute yourself. Anyone has the question? Okay, I just raised the question for you, for the audience, Mr. Dongwei.
Yeah.
Someone asked, what do you suggest for the 11 to 12 grader kids to prepare the internship for STEM project in big corporation like ARM?
Yeah, so 11 and 12th grade. So these are the juniors and seniors in high school, right? Yeah, so sometimes in that age group, things potentially could be a little challenging, because I think the companies typically not necessarily hiring the high school kids, but that's not entirely the same situation across the board. So I think it just means that you need to look harder and maybe, knowing more people and asking, and sometimes there are opportunities. I've seen some of the, the high school 11, 12 grade people having these kind of opportunities, but it's just a little rare. It's a bit more challenging. I think when you're into the college years, it becomes much more easier, I think.
Okay, thank you. And one more question from Wei Hong Kwang.
Hello,
Yeah.
Hello, my name is Wei Hong Kwang. Hello, Mr. Dongwei. I am a senior student in San Jose State, and I'm getting graduate next year. And during the job research process, I found it's really difficult for us to find a job. Like for the new graduation student, we even need like 5 years experience to get into a entry-level job. So do you have any suggestion for us how to start our career, or how about the CASPA get some opportunity path for us to get into this semiconductor or electrical engineering industrial? Thank you.
So you are in the college, almost graduating?
Yes, I guess so.
Yeah. Okay. Yeah. So yeah, I think in that case, the opportunities should be a little more, actually a lot more than the high school side. I think the suggestion is to build your networks, right, through LinkedIn, through whoever you know. I think it's kind of interesting, like from the person who are looking for jobs, you may feel like there are not a lot of opportunities out there, but from the people who are actually hiring, I have done a few in the last year. So actually it's very hard for us to find people who have the right skill set, right, and the submission of the resumes. So I think it's about the networking, right? I mean, on the both sides, it seems like there is a difficulty finding job opportunities, and from the hiring side, it seems like we're having a hard time finding the candidates. So I think using Casper, using LinkedIn, using all kinds of possibilities out there, doing networking, I think that's very important. And there are a lot of jobs. I mean, sometimes you shouldn't just look at maybe AI is very hot these days, right? A very hot subject also means that there are a lot of people competing for the same area, right? So just try to develop yourself to be broader, in terms of disciplines, to be much more broadly applicable, and rather than kind of focusing on only one area.
Thank you, Dr. Dongwei. I think what you really wanted to answer is the skill set, not only the hard skill set, but also the soft skill set, like the build a connection and present yourself and selling yourself, just like what Apollo said, skill sets, right?
Yeah, exactly.
Yeah, thank you.
That's very important. Yeah.
Yes. Thank you, Mr. Dongwei. And thanks for your great sharing. And yeah.